Thank you, and thanks for having me here again. Last year I did a presentation on how to use Marvin Sketch for structure editing inside Biochemfusion's products. This time I'm going to talk to you about how Biochemfusion's products are able to interface directly to JChem for Excel. And the subtitle is always sort of a reference to last year's presentation that was an API-free solution. This time it's about using the JChem APIs for this. And the talk will be about how you can get proteins into JChem for Excel. So it's not about getting more muscle into JChem or putting JChem on an Atkins diet. It's about being able to work on macromolecules inside JChem for Excel. When we're talking about small molecules, we tend to describe them as networks of atoms and bonds. And Chemaxon's got all these great toolkits for that. It's also got JChem for Excel, so you can do all your structure manipulation and analysis right inside Excel. That's comfy. Macromolecules are different beasts. They are so large that we tend to do a more coarse-grained description of them. So we describe them as linear or even cyclic chains of one-letter residue codes. So it's the domain of sequence analysis. Biochemfusion has a product that's called Proteax for spreadsheets. Proteax is the toolkit that lets you do sequence analysis and manipulation. And since it's called Protex for spreadsheets, it means that it runs directly inside spreadsheets, including Excel. So we've got these two products running inside Excel, and we've got these two very different ways of describing molecules. So, can we break down this wall? Yes, we can. And I thought about a use case for that to show you a demo of that. And since JChem has some excellent pKa prediction, I thought, okay, it should be able to do excellent PI prediction as well. Isoelectric point is quite interesting for protein chemists. So I took finding a data set. I was fortunate enough to attend a lecture in Copenhagen 2 years ago. These guys from Brisbane, Australia, they've done some interesting work on toxins. Toxins are small peptides isolated from some venomous critters they found in Australia. I have the impression that all animals in Australia are toxic somehow. And what they did was exchange the disulfide bridges with diselenide bridges. That stabilizes the protein, which is good because they use these peptides as drugs. So you get more stable release. And this is Protex for spreadsheets running inside Excel. So you have the Protex menu. And I use the import from server function here to get hold of one of the toxins from UniProt. Then I did the exchange the cysteines with the selenocysteines by using these substitution expressions here and apply those to this sequence up here. And you can see it's just a normal Excel function that you get when you install Protex for spreadsheets. And then you can manipulate these sequences. So the first one here is imported from database. And these four are calculated right inside Excel. Since we've got JChem for Excel installed too, you'll get these two lovely buttons here with the beautiful Chemaxon logo, used by permission, thank you. And we're just dying to press that button here. I selected the data over here. I'll press OK. And we have live JChem structures right inside Excel now. So now we can use all the JChem functions on these structures. And I'll use the function wizard to find the isoelectric point prediction, select the molecule, and press OK. And as you can see, exchanging the disulfide bridges to diselenide bridges doesn't really change the physicochemical properties of the molecule, which is a good thing. And just for fun, I did some terminal modifications too, biotinylation of the N-terminal and replacing the amidated terminal with a straight OH. And that does change the PI quite a bit. And why would you want to do that? A good example of that is changing the PI of human insulin. Sanofi Aventis did that with their glargine analog, where they substituted a single residue and added 2 more residues to the C-terminal of the B chain. That shifts the isoelectric point, which changes the pharmacokinetic profile. So, yeah. So comparing with the PI of normal insulin, found it on the web, it's almost ancient scripture, this thing, 1932. So the PI of normal insulin should be around 5.6 to 5.65. Importing that into Protex or spreadsheets, doing the substitutions described to create lances, getting that into JChem. Wow, is that between 5.6 and 5.65? Oh yes. And seeing something else. So just to sum it up, my experience with getting things into JChem for Excel was very pleasant. It's very easy to use these APIs, and if you can export your data into something that's industry standard, then it's very easy. So if you can code a little bit in VBA, it's a walk in the park. So I'd just say, go and grab these excellent products and try it out. Grab JChem for Excel, grab Protex for spreadsheets. Just got a new release out this Sunday that has the interface built in for JChem for Excel. And come and see the poster, the tallest one. So thank you.
Thank you very much, Jan. The next presenter is Charles Fleming from Deltasoft.